So we are pleased to present you tonight an introduction to LLM and multi-agent system using LangGraph. It's an open source framework. So I'm here with Alex, Alejandro, and Younes. Both are my colleagues. We are all machine learning engineers at Visium. So first, I will do a quick introduction about Visium, what we do, and our mission. Then I give the floor to Alejandro that will talk about the theory of LLM and agentic AI. And on the second part of the workshop, we prepared a Jupyter notebook for you. And we have a repository. And Younes and me will dive into this. Okay. Let's start with Visium. So Visium is a consulting company founded in Lausanne here by former EPFL students. And we have core expertise in machine learning, but also expertise in strategy, architecture, cloud engineering, data engineering, and analytics. We help organizations across Switzerland and Europe to become leader in AI and data, or at least to develop them in their AI journey. So these are a few numbers. So we are more than 50 employees. We have many clients, mostly in Switzerland, a bit all around Europe also. We have a partnership with EPFL, ETH, and also all the main cloud platform like Azure, Google Cloud, AWS, and the data platform like Databricks and Snowflake. Yeah. So we work with many different companies, different sector, but also at any stage of the AI journey. So we can work with this kind of company that they just begin with data science. They don't even know the term machine learning, to the one at the top that have a data science team that work with AI every day, that have many use cases. So we can do team extension with them. We can do small projects. The goal is really to assist them to go to next stage and to unlock the power of AI for many of their projects. So here are just a few use cases that we did recently. As you can see, it's a wide range of sector and company. Just for the time, I will just show you this one. So we did a model to generate automatically a new chemical formula for a big chemical company. And it helped like chemists to reduce the time to market. And before they had to do a lot of work just to create a new chemical formula for an application. And now just in a few minutes, they can do it and iterate on this formula. Yeah, we have like 4 offices, 2 in Switzerland, 1 in Spain, Valencia, and 1 in Bosnia, Sarajevo. It's growing rapidly. We have, I think, 20 new members this year. And yeah, we do many events. We gather regularly together. There is, as you can see, it's quite young and dynamic atmosphere. So yeah, at the end, we will give you the open position. And if you want to have more questions on Visium, feel free to come to us at the end of the workshop. Yeah, there is still this slide. So most of the employees come from EPFL or ETH, as you can imagine in Switzerland. We offer also to all our employees education day and education budget to upskill and yeah, advance in their career. We collaborate across projects and in the same project. So usually in one project, we are many engineers working on it. And this means that we deliver high quality work and use case to the clients. And as you see before, we work across many different sectors like healthcare, finance, consumer goods. Yeah. So now I give the floor to Alejandro.
Yeah, thanks, Lucas. Okay, so this workshop, actually, it's a bit more intended, and afterwards we'll see it's more of a programming workshop. But of course, first, we will introduce a bit the core concepts of the workshop. So first, the idea is in the workshop, we will try to build an agent. And first, let's define like some concepts for building agents. First, the LLMs. LLMs are really the basics about agents. Today, we talk about agents thanks to LLMs. So these are transformer-based models, NLP models, and they are trained on vast amounts of text data, and they are capable of understanding and generating text as humans. So these models are, they do autoregressive generation, and they produce text by predicting one token at a time. We can think of tokens as words, but actually they are a bit different. But here then the idea is we give some input, then the model generates a token, like GPT is based on the transformer. After this goes again into the input of the model, and then we generate a token, another token, and it goes like this. And actually, when we use, for example, like ChatGPT, we just see the final output, let's say. We don't see like this process. And so this model, they have massively trained on billions of text data. And they actually have trained trying to predict mask tokens. So we give them like lots of text sentences. In that text sentence, we mask some of the words, and then the model tries to predict these words. And this is how they are trained, and this is how they learn a bit the structure of the language. And thanks to this massive pre-training, it's why they are actually today really good at understanding it and generating text as humans, actually. And also, they are zero-shot learning models, so they can perform tasks they weren't explicitly trained for. So, for example, you can use today like these models like ChatGPT, for example, you can use it for text classification without the need of seeing labeled data, which 4 or 5 years ago, it was impossible. Like to train a text classification model, you would need to give a lot of examples, and then the model would learn based on the provided examples. Okay, so these LLMs, they have revolutionized AI thanks to the language capabilities, but this is just the foundation. And today also we're going to present what comes next. No? So thanks to what we said, this understanding and reasoning capabilities, we can also teach this model to interact with tools, external tools such as APIs, and then they will be able to make interactions and connections with the digital world, and going from generating text content to executing tasks and actions. And here is a bit the schema that we will follow today. Like first we have the LLMs, and then we power up these LLMs, giving them tools, also a system to make planning possible. And finally, we end up with autonomous agents. So the future is agentic. So what is agentic AI? These are systems designed to act as autonomous agents capable of performing tasks with very minimal supervision. So there's some important words like autonomy. They have the ability to operate independently, so no supervision. Also, they can adapt to the environment. Like depends on what is the situation, they can adjust the strategy, and then they can decide the action based on that. And also we can teach them to learn from past actions, so we can improve them over time. And at the beginning, we were talking about LLMs and Gen AI, which are good for creating content. But then the idea now, like, and what we will present after is more agentic AI, which is more action oriented. So we are going beyond content generation, and we are going more into decision making and making actions. And now we will deep a bit more dive in the concepts that we need to create these agents. So in the introduction, first we presented the LLMs, and now also like how to equip these LLMs with tools. So LLMs, they can be augmented with external tools as document retrievers, web search, code executors. And then the idea is we can teach these LLMs how to use these tools, and then when we interact with the model, it will learn maybe if he needs to use one of the tools to provide a better output to the human. And this is one of the bases to have like agents. Afterwards in the workshop, we will give like an example of, for example, how we can provide to an LLM, providing like a document retriever and web search, how the LLM can connect to the web and give us like much better information for financial analysis. But afterwards, Younes will show us better. And the other very important concept also is workflows. So workflows are a system where the execution path of LLMs is predefined, okay, to some extent. And they are really good because they offer like control and consistency for complex tasks requiring more than one single LLM call. So to illustrate this better, the clear example for this is prompt chaining. So in prompt chaining is a type, maybe the simplest type of workflow, where we have a sequence of calls to an LLM. I didn't say it, but when an LLM call it's like a call to the API of OpenAI, something like this. We give it a prompt, and then it gives us an output. This could be like just one call. And imagine, to give an example, if we want to ask to an LLM to act as an interviewer, so we will give like, so the idea is, okay, you are an interviewer and he's interviewing me. So the idea is he will ask questions. And then the idea would be, okay, then let's define like a workflow, because based on my answers, maybe like if he asks one question and my question is not very clear, maybe based on my answer, he will try to ask more questions about it, so it becomes clearer. And if the answer was pretty clear, so maybe it goes to the next question or something. So it's defining this the workflow of different LLM calls to give a much better workflow. And this when developing with LLMs today, like many applications are developed through LLMs, and this is really important to have consistent outputs. And yeah, and at the end, if we combine all of this, we end up with agents. And at the end, agents is a bit like we are powering LLMs with external tools, also with workflows. And then we have like a more sophisticated system where the LLM can interact with human, can also interact with the environment. And based on the situation, it can take like different actions thanks to also like these workflows that we defined. And this is a bit the idea, and what we will show now in the workshop. It will be much clearer also. And just also we gave like some examples on some papers there are about also building agents, and what to give a glance of what are the capabilities of these agents. So first, this paper, well, we have to go a bit fast, but this paper is, we will also give the presentation with a GitHub repository, so you can check the papers. And this is virtual lab, and it's quite interesting what they did. Like at the end, it's a laboratory where they define like LLMs, and you can think of it as we tell to an LLM model like, okay, you are a principal investigator, to another, you are an immunologist, and then you have like different LLMs, and each one has this role. And the idea is the principal investigator is going to a bit like to supervise the other LLMs, and also you have a human on the loop that will give a bit of feedback. And actually, like they did using like this virtual lab, like between the different connections of the LLMs, and thanks to the human user also providing feedback and some guidance. they did like some pretty interesting discoveries. And yeah, I really recommend to read the paper. And also another like quite another paper that is really worth to read is about the Stanford AI Village. So some researchers, like similar as before, they define some characters that are powered up with LLMs, and each character has a biography. A biography would be like the prompt to the LLM, like, okay, you are this character, in your day-to-day, you do this type of things. And then also they define like some relation, like this is your friend, this is not your friend, like some things like this. And then they run the simulation. And it was quite surprising because even like you saw how the characters in the simulation, like they were behaving a lot like humans sometimes. And even like at some point, it was the party of one of the characters and they organized a party and everything. So it was quite interesting. Here we gave a video, we cannot see the interactions in this video, but the idea is like you have this village and you power up with this LLM, they can take actions like walk and everything, and they also can engage conversations. But all of these papers also are led in the presentation. And I don't know if there are questions, but now the idea would be to move with a workshop that we prepare. So also you can see like the practical thing and better.
Yeah, and just for beginning with the practical example, I want to give you an introduction on long chain and long graph. So that's the two frameworks that we will be using. So who has already used long chain before or long graph? Nice. So one person. I mean, it's good. Yeah, it's the goal of this workshop is for you to learn it and to use it. So long chain, it's an open source framework and it's used to build large language model application. And also it can connect to external tool like Alejandro showed before. So you can create a simple agent with it. And it can also connect to data source. It can have memory and even multi-step reasoning system. So it's not just about doing a simple chatbot, but you can really use it to do more an agentic system where the system makes decision, call tools, and plan action. So you will see it's really easy to use and it's easy to combine multiple LLMs together, even using different tools. And the ecosystem is really rich. The community is very large and there is a lot of tools that is already predefined. In this workshop, we will use Yahoo Finance news. It will give you the news of some finance of company. And here are the most basic tool of LongChain is the chat OpenAI, and you can initialize your model here. There is like two important parameters, the model and the temperature. The model, you can choose whatever model you want, like for example, GPT-4, GPT-3, but also open source model like Llama or anything LLM related. And the temperature regulates how much the agent or the chatbot will give you a response that is different, not conservative, really original. So for example, if you put a temperature of 0, it will give you almost always the same response to the same input. While if you give a temperature of 1, it will give you different, more exotic response. And with just that, you can use the model with the method invoke and a list of messages. And the most important message are the system one. Here you define the goal of your chatbot or your agent and the human message. This is your user query. like when you do in ChatGPT. And long graph, so just to say long chain, you can do agentic system, but it will be quite simple because you can see long chain as a chain of different LLM. So it will be really linear, but you cannot do feedback loop or like complex interaction between agents. For example, if you want two agents that have a conversation between each other, you need to use long graph. And long graph is, it represents the agent and the interaction into a graph system. And it's also open source and it's just built on top of LongChain. And if some of you already use NetworkX, the API is quite similar. So you can also see the number of nodes and the number of edge, and even display the graph. And it helps to move more than just simple agents and to do more complex, dynamic, and iterative AI workflow. And in the README, you will have instruction on how to create an environment using Conda or UV or whatever you prefer. And that example to show you.
Yeah. And then they will go through a Jupyter notebook, and that will need some Python libraries and the API key.
Yeah.
So now that we installed the Python environment, we can set up your API key. So we put an example here, this file called .env.example, in which you're going to add your open API key. But in reality, what you need is a .env file, which will take what's in the example, copy paste it here, and then you're going to replace this with one of the keys from the workshop. I'm going to go and I'll hand over the notebook to Luca for the start.
So I will just do the first part of the notebook, and then Younes will do the second part, a bit more complex agentic system. So I hope you all have created an environment and also have a key in the .env. So now that we set up everything, we can begin the workshop. And the goal of the workshop is to do a bot, a finance analyst bot. And for that, we will use the model GPT-4 Mini. So only this model will work with this key that you have. And the temperature, you can set it different. If you want, you can even set it to 1 or to 0, whatever you prefer. So the temperature regulates how conservative the response is, and the temperature of 0 is really conservative. And now, like the slide that I showed before for LongChain, we will just create this model. So let me run this. Using the chat OpenAI and the model that we fixed. And we have two messages. The system message that indicate the purpose of the bot. So here, the chatbot is a financial analyst, and it will try its best to respond to the request of the client and also to give a portfolio allocation, basically to give him an investment strategy. And here, the second message is a human message, so it's the prompt of the user. So you can change it if you want. You can set up your age and your bank account. I don't know. Let's run it. So you just need to create this messages object, which is a list of the system message and the human message, and to use the method invoke of the model. And here, if you look at the response, you have a response of the model. So this model is the mini version of the famous ChatGPT model. So if you use it on ChatGPT with the prompt before, you will have really similar response. And now I hand over to Younes to explain a more complex agentic system. So what will be, yeah.
Everyone, I'm back. I'll start by a small tutorial on a simple agent that has access to a tool called Yahoo Finance. So in short, Yahoo Finance is just this website to articles from this website to one. And in this example, we're going to show you how to do that. So in the first part, we import this tool called Yahoo Finance News Tools. It's a tool which, when you tell it, when you give it a code, for example, AAPL or Zern or MSFT for Microsoft, it's going to give you a list of articles and their contents from this website, so from Yahoo Finance. So this agents are going to be the prompt, the tool that it uses. And of course, the LLM that's going to use the prompt and the tool to give you financial advice. So at the start, you have to call the model once to ask it, okay, you basically tell it what to do, in the sense that you tell it you're a financial analyst, you have access to this tool, that's Yahoo Finance tool, and here's how you call it. That's essentially what you're gonna have inside of this prompt. So some examples of how to call it, like, okay, if you want to call Apple, you have to use the AAPL code. If you want to call Zurich Insurance, if you want information about Zurich Insurance, you need to use this code. And based on these examples and the sort of character that this tool needs to have, it's going to try to give you an answer. The first time you call it, it's only going to say, what do you need to ask the tool? So it's going to give you like a format, like just a dictionary actually, with the exact information you need to send the tool. So in this case, it's just which codes are you going to send the tool. So that's what you're going to have here inside of financial analyst tool calls. It's just going to be a list of these codes that you get after calling it for the first time. The second time you call it, you're going to put everything into one big message. So the first part being the tool prompt. So the part where you tell the LLM, you're a financial analyst, here's how you call this tool. It's going to have the human message. So, okay, I'm a student, I'd like some tips on how to invest my money. And then the last part is going to be all the information that you collected thanks to this tool. So it's essentially going to be like the links to these news articles and their contents and their titles. So we're going to have like extra content. So basically it's going to be like, oh, OpenAI bought Microsoft, and I know Apple did this year, and this is relevant to this person that lives in the US. You're going to give that to your LLM at the end, and you're going to ask it, okay, now with all this information, give me some financial advice, and it's going to output it here. Now, actually, I don't know if you ran that before. Ooh, sorry. I'll just rerun everything before. I forgot to run these from there. And it's going to take a few seconds, which is normal. Many seconds. So actually, I can go into that in a bit more detail. So Yahoo Finance model here is an LLM that is binded to tools. So it's an LLM plus a tool. And the tool is an object that can call Yahoo Finance and output a list of articles. So they will pick information from articles in Yahoo Finance. Exactly. Yeah. Sure. You've got to set all the tools you want to access to from the LLM. Exactly. Yeah. Okay. predefined list of what you done. Yeah. Yeah, and you can even build them on your own. So right here, above here, we defined the list of tools to just be Yahoo Finance News tools. But you can put any other, you can put like a calculator, you can put like integrator, or like you can just create whatever you want. In this case, if we go deeper and look, it's a bunch of code. Let's not go into the details here, but there's this library called Y Finance, which gives you access to the website essentially. And what all of this does is it takes the query from the LLM, it uses Y Finance to call the website, and then it formats all of this output so that you just have like a clean list of titles and articles. So that it's easier for the LLM to use later. But there's like a lot of processing here, which we figured is probably a bit too much details for this short presentation, but just know that you can make any tool that you want. If you want to make like a simple tool, just here where like we replace everything, I just want a calculator, you can also do that. Or like whichever more complex thing that you want. Yeah.
Is there a way to enforce that for every request it will use the tool, or it will not necessarily if like the request is not related to it? Or
That's a very good question. So in our case, it's always going to make a request, and then we're going to force like, so if it gave us the requests, we're always going to run them. But that's actually a good question. In this case, we're not forcing it. Yeah.
Because if it would bind to two tools, for example.
Yeah.
Then, yeah, I guess the LLM will take it.
Yeah. So as far as I know, there's no way to guarantee it, but we could maybe check after and then put it on the repo if that's the case. It's a really good question. Let's put that. Oh no. Okay, I think there's probably too much people on this, so I'm gonna take. So I think since we're all trying to do this at the same time, it's a bit slower and we just had a timeout. We're just seeing if maybe with another API key, it's gonna work out. Tends to happen during workshops. Yay, it worked. So here's an example. Apparently there were some reports about short-term option trades in Microsoft and also NVIDIA. And in this case, the question was, user question, how does Microsoft feel today comparing to NVIDIA? And we have some like slightly relevant advice. So there's a report indicating that short-term option trades for Microsoft could yield triple-digit gains, suggesting bullish momentum in the stock, blah, blah, blah. I think now it could be interesting for us to start the agentic part of the workshop. Now that, yeah.
How bad does it go?
Oh, this just gives you like the 10 most recent articles.
Okay, so it's very recent.
Yeah. Yeah. If you would like something more complex, I know with Y Finance, you can take the history of a few months. You can even like right here, it's just like title of the article and content of the article of the last 10 ones. If you want though, you can take like stock exchange information of like Microsoft, for example, or of these relevant ones up to a certain number of months. And that's something that you can do in Y Finance. So the exact place where you're going to modify that is inside of this class. So inside of Y Finance tool and inside of here and run. So what this does, so like exactly here, it just takes like the 10 last articles. If you want, you can make that much more complex and like much more relevant. But for like the sake of the example, we went with the simpler option.
The types of information you can analyze only text, or for example, can I also input like, I don't know, charts?
Very good question. So now it's only text, so title and article content, but you could format, like you could take data frames, you could take Excel files, whatever you want, just format it into text after, and you're good. Any other questions? Or we can, yeah, sure. Oh, yeah, go ahead.
If I understand correctly, it's asking about the 10 last
News articles, yeah.
Or how do they get like I'm talking about NVIDIA, like a stock, how does which stock gets queries or like this relation?
Very good question. So the first call here is going to give you a list of which stocks to call. So actually, maybe we can like open this like tool calls so that you can see better what's going on behind the scenes. So the first call to the LLM is going to give like this formatted input for the tool. It's going to tell you, okay, you need to call the tool with Microsoft and you need to call the tool with NVIDIA. After you call the tool with these two, you're going to have this input here. Let me show you what's in there. Maybe I can do this. String tool call ID. So these are just the titles actually, but let me get out the news list. Yep, there it is. So yeah, kind of gross output here, but you have, I don't know, Magnificent 7 stocks, NVIDIA, stock rally, investors, business daily, some things like that. These are just the titles. So you're going to also have the content of these articles that's going to be given to the LLM. And yeah, so that's pretty much it. So this is like the information that you're going to have, that the LLM is going to have to give its more informed opinion. Yeah.
Thank you.
Welcome. Anyone have a question? Okay, I guess maybe we can move on to the next part. So now that we've showed you a small example of the financial analyst agent, I'm gonna just show you how to put it all together. There's a tool called LangGraph that Luca presented right before, Luca and Alejandro. And we're gonna build a small graph here that's gonna be our multi-agent system. Each agent is a box here. So the first one is a client interface agent that's gonna take your user request. Go ahead, yeah. Yeah, I think maybe I can wait a little. The agentic part of the workshop, why you all came here. So I'm going to start by defining different parts of this multi-agent system. You can call this a graph because you have different components and they have to be run sequentially. The first one being the client interface agent. It's basically just an agent that's going to take the user input. So, hey, I'm a student. I have this amount of money and I want to invest it in US stocks. And then it's going to rephrase it in a better way for the risk advisor and the financial analyst agents to help you. Now, the risk advisor, actually, I'll start with the financial analyst. The financial analyst, in short, is what I presented to you right before. So it's just an LLM that has access to Yahoo Finance, in short. The risk advisor is another LLM that is meant to give you advice only on risk. So what if you invest in these stocks that seem really good right now, but maybe you might lose money because they are really volatile and sometimes they lose a lot of their value when something happens in the market. So kind of like each agent here has their specific task and has access to specific tools. The risk advisor here doesn't have access to any tools, but the financial analyst has access to Yahoo Finance. Now, both of these are going to give their output, their advice, and this is going to be compiled by one last LLM, the synthesizer. And its objective is just to look at these two outputs and give you like a kind of like overall financial advice. So I'll go through the different blocks here. I think I'll skip financial analyst because I just spoke about it. First, the client interface agent. Yeah, maybe some important things about LangGraph. So there's really important component about LangGraph is that you have this state. So while you're running these different parts of of your graph, of your multi-agent system, you need to keep track of what has been done before. And you do it with this thing called the state. It's this class that has different attributes that you can define on your own. Most of them go into messages. So our first input, so like the user's question will go into messages. And the advice that comes from the other agents, so from the financial analyst and from the risk analyst, are going to go into these two attributes. So financial analysis and risk analysis. Now, a bit more in detail, I'll go a bit more in detail about each of these agents. So first, the client interface agent. So basically the one that's going to summarize, that's going to like reformulate the user's question. It has one simple component. It's just the prompt. You're just gonna prompt it to do this reformulation. So your client interface agent, your role is to take the user's investment related question and reformulate it, in short. This is the structure of this agent. You have it's unique to a line graph. You have to define it as a function that's going to take a state and that's going to send a command. The command is something that's going to tell LangGraph, okay, you are at this part of your multi-agent system, and once you're done, you have to move to this next part. Since this is the first part, it takes the input, the state at the first point, so which is just the user's input, and then it moves on to the financial analyst and the risk analyst. So, okay, I reformulated the question. Financial analyst and risk analyst, can you help me with this question? I think I already talked about the financial analyst here, so I'll skip through this part. And now I'll talk about the risk analyst. So the risk analyst, again, is like sort of simple. It's similar to the reformulator agent. And all it does is that it's going to evaluate the question, but only from a financial risk perspective, to be cautious and make sure you don't lose all of your money. So it only takes the reformulated question, and then it's going to give this answer to the synthesizer, just like the financial agent before that also gives the answer to the synthesizer. Now I will skip to the synthesizer node. The synthesizer node has a very simple objective. It's a financial advisor and has to combine the insights given from both of them. So from the financial analyst and from the risk advisor agent. So again, just an LLM with a specific prompt. And we combine all of these. So we combine the messages from the financial analyst, from the risk analyst with this prompt so that this LLM is going to give us a more informed answer. And this is the last node of our graph. So it's the part that's just it's at this point that we just end this multi-agent system. Now, LangGraph has a very simple API. It's once you've defined all of these nodes or all of these agents, you can combine them into your graph in a really simple way. So you just need to tell it, okay, we're starting from the client interface, the one that's just going to reformulate your question. And then we're going to define all of the other nodes. So client interface, the financial analyst, the risk analyst, and the synthesizer node. And since before, in every single node, we've defined where it starts and where it ends. So you start by taking the state and you end up, like for the synthesizer, it's just the end. For the risk analyst, you have to go to the synthesizer after. For the financial agent, you have to go to the synthesizer after. For the client interface node, you start at the first messages, and then you give your message to the financial analyst and the risk analyst. So you define all of these when you define the nodes. So all you need to do here is just to tell LangGraph, okay, here are my nodes, and you already know how to connect them. And here you do that connecting by compiling them. Now, finally, the part you've all been waiting for is to call this multi-agent system. I'll just check where we last ran this. It was here, and then I'll run everything under it, and then jump to the end. And we also chose to show you which tool calls the financial analyst is making. So now what you see here is a call to the Apple stock, to the Microsoft stock, and to the Amazon stock to search for relevant articles in Yahoo Finance for those stocks. And then it's taking a while, but the answer is coming up. So it's asking for everything. Yeah, sure.
You define in each node corresponding to each agent where to go to next. Is it possible to define this direct direction when building the graph later on? Or do you have to
Alex?
previously when building each agent where they will be?
Sorry, could you repeat?
I mean, each, like for example, the first agent, the client interface goes to as a command to go to financial analyst and risk analyst.
Exactly.
So we define it there, but so that's how the land graph. That's how we. I believe that when we do the add node method, it understands how to connect the
Exactly.
Yeah. Is there a way to define these connections only in the add node part? Or
yeah, like usually, like with the add nodes, you're defining the nodes of the graph, and then you need the connections, like with the edges of the graph. And usually these edges are represented by functions that you will code yourself. And here we define like this way, but we could have used other functions there to build a much more complex graph with many possibilities, and even like maybe functions that depending on the output of the LLM is going to go to another node or to another one. Like really, like you can build the graph as complex as you want, but you need to define the edges, like because like this line graph, like depending on at the end what it's doing is depending on functions and on the output of the LLM, line graph can know because of the workflow to define where to go afterwards. Don't know.
Does that answer the question? Okay, great.
We're trying to understand the level.
Yeah, sure.
What does exactly use it? Like to write go to, but like to do things like is it like going to ransom one of the other?
So yeah, not necessarily. So in our case, let me show you. Let me go back to this graph. Here, it's going to send them. It's going to go to them simultaneously. So risk advisor and financial analysts are run at the same time. And once they're done, they're going to send their output to the synthesizer. But once they're both done. So if you have something a bit more complex, something that we didn't talk about during this workshop is you can have some loops if you want. So for example, you can have, I don't know, financial friends or something like that, where one of them keeps on giving financial advice and the other just rates it from 1 to 10. And once this financial advice is above, I don't know, 9 on 10, then it stops. Or it can be like something else, like a video game, where there's like two characters interacting until some specific action happens. And you can define all of that, but not when you're defining the graph at the end, but inside of the function. So when you put your command, it's going to be something like an if-else inside of the final output of the multi-agent system, a very large financial advice. I'll spare you this. I spare you the details, but essentially you can see that it's taking into account the stocks that have been called by the financial analyst. And I think that it's giving you a financial strategy at the end.
Yeah, like Microsoft.
Yeah, so this is just for the sake of the example. You can have a multi-agent system that does anything else. I don't know, for example, I don't know if you've played Dungeon and Dragon. You can have something, you can have like a dungeon master and some characters, or you can have, I don't know, a small lab. I think it would be interesting for you to open like the example that Alejandro talked about later. There are really large papers about this, we went for something really simple. There's definitely like a lot more things that you can do, but we tried to fit it inside of this short session. So I think, yeah.
Yeah, I guess read this and yeah, I mean, it's just to give you the link. If this is all the open position we have at Visium, and if you are interested, just scan the QR code.
Here they will see everything.
Yeah, you will see everything. Yeah.
So
I think we will have also, maybe it's not there yet, but we will have also internship for September.
yeah. So
Yeah.
if you'd like to apply, just scan the QR code and you'll see the open positions. And usually we have like internship positions open at like the start of the semester.
Yeah.
In case.
There are also full positions.
Yeah, that too.
Also full-time position. Yeah.
In not in all of the offices, so it can be either Lausanne, Zurich, Spain, Sarajevo. Yeah, yeah, not for engineers though. Yeah, so that's pretty much it. I guess if you have any questions, we'll be next to the pizzas, and otherwise, you can shoot us an email and we can try to answer that. I think there's already some comments that we had before, and we'll probably see some updates to the repo the next day or so.
Yeah. Thank you, everyone.
So thanks a lot for this workshop.